Introduction, and thanks to Ken and Jamie for the invitation to be here today. It's always a privilege for me to follow Dr. Ron Howard, and I've had the privilege of doing that for about the last 10 years. And I've learned a lot of great information from him, particularly in the areas of diagnostics and recognition of symptoms, and I guess really kind of an overall applied plant pathology perspective, and I've really appreciated doing that, so it was another privilege for me today to follow him again. I'm going to be talking a little bit today about some cereal diseases that have been a bit on the rise recently. And I'm going to start by acknowledging some of the people that provided information and photographs. And so that would include Tom Grafenhan and Cheryl Tittlemeyer at the Canadian Grain Commission, Kelly Turkington and Jim Menzies at Ag Canada, Trevor Blouse and Kevin Zajac at 2020 Seeds, and Dr. Ron Howard. There's also some images presented here that I collected from the Western Committee on Plant Disease slide set. So here's where we're going to try and go today. With respect to Ergot and Fusarium, we're going to talk about the disease situation or status, talk about how and why disease occurs, and finally come to some management recommendations. So let's start with ergot. So here's a slide taken from a publication from Jim Menzies and Kelly Turkington showing the percent of wheat samples with ergot. And so the percent wheat samples is on the vertical axis, and the years 2000 through 2012 are shown on the horizontal axis. And the dark line is the Alberta statistics, and the dashed line is the Saskatchewan statistics. So there's a couple of things we see from this graph, and the first one is that ergot can tend to be very sporadic in its occurrence. It can be show up at minimal levels one year, and at the next year we see tons of it. So we especially see that in the Saskatchewan statistics, where it flares up and then kind of disappears for a year and it flares up again. Now in Alberta we can see that over the last 5 years, the incidence of ergot in grain samples has been increasing over time, kind of steadily. And so that's concerning. This is a graph showing two different things, and it actually has the 2013 data as well. The bars represented on the the left-hand side, that's the percent samples downgraded due to ergot. And so these are data from the Canadian Grain Commission's harvest analysis. And so the bars show how many samples, the percent of samples that were downgraded due to ergot, and the numbers go from 0 up to the highest bar there is about 20%. And then the line shows the percent of ergot. So that's kind of a measure of severity. How bad is the ergot in the samples? And you can see that that tends to bounce all over the place, but a general trend towards increasing. So the incidence and severity of ergot both have been increasing over time, over the last 5 years. So how and why does ergot occur? A couple of things we need to look at here with how ergot does its work. And I'm going to compare and contrast ergot and Fusarium a little bit. And one of the things that makes ergot different than Fusarium is that it forms this overwintering structure called a sclerotium. And so these sclerotia can survive in the soil or in the seed bin for a year, sometimes two. And then in the spring, when the conditions are right, they'll germinate and they'll puff off spores that begin infections. The second thing I want to point out with the ergot life cycle is that there's a second spore stage where an amber colored ooze will come out. We call it honeydew, and it contains conidia, different type of spore that can be splash dispersed, and it can also be transmitted by insects moving within and from crop to crop. So there's kind of two ways that ergot gets into fields. The first is through germinating sclerotia and the ascospores that puff off. And the second is this honeydew stage where the asexual conidia spores will be dispersed. So let's take a look at what these might look like. Here on the left-hand side are some ergot sclerotia in a harvested grain sample, and then on the right, an example of a sclerotium that's germinated to form the stalk with the sporulating head on top. And so this is how the cycle would be initiated in the spring, is with these germinating sclerotia. When those ascospores infect heads, they'll then form the honeydew stage. Now this, you don't often see this dramatic amber ooze. Usually what you'll see is heads that have ooze that's on it, but then dirt. So the heads appear dirty or dusty. And so this is a stage where things can be spread further. One of the important things to remember with ergot is that it's not just the pathogen on our cultivated crops, but really just about any monocot host can potentially be a host for ergot. And so here we see wheatgrass and brome with ergot symptoms on them. And in fact, ergot oftentimes will get started first in the grasses and then move into cereal crops via the honeydew stage. Here's an example of some cultivated crops with ergot symptoms. On the left, there's barley, in the center, oat, and on the right, triticale. And then we also have rye and wheat as hosts. So these ergot sclerotia replace the kernels, and they oftentimes will become loose and dislodge and land on the ground, but a number of them also will end up in the harvested grain. And so there's kind of three real problems associated with ergot ending up in the harvested grain. The first is that you have ergot sclerotia instead of plump kernels, and so there's a direct yield loss due to ergot. The second is that if you have more than 0.02% by weight of ergot in your samples in Durham, it'll be downgraded to a number 2, and more than 0.04 in other classes be downgraded. And the last is that it can be not only a problem due to downgrading, but also market acceptability because of the poisonous mycotoxins that are present in the sclerotia. So feeding it can become an issue as well. So let's talk a little bit about managing ergot. And really the take-home message that I'd like to extend to you today is that there isn't just one thing that you can do that's going to prevent ergot from being a problem on your farm. So we're going to talk about a number of things, and then it's important to remember that multiple management tools will probably have to be integrated to get consistent, successful management of ergot. Now, one of the exciting things on the horizon is that right now we don't have any really resistance to ergot in any of our classes of wheat or barley, but that on the horizon that's going to become a reality. Now, the work is being done by breeders at Ag Canada in Swift Current and Winnipeg, and I'm not really connected intimately with that work, but my understanding is that there will be up-and-coming varieties that will have some level of increased tolerance. I don't think it's going to be complete resistance, but varieties that will do better, cultivars that will do better against ergot than the ones we currently have. So that's exciting, and it's something we can look for in the future. Right now, it's not a tool that's available in any of our cultivars. So how do we manage it? Well, the first is, when we looked at the disease cycle, there were those two ways that the fungus infects the host crop: the germinating sclerotia and the honeydew stage. So if we can reduce the amount of sclerotia, the primary inoculum source, that's one way we can manage the disease. The great thing about ergot sclerotia is that they don't survive for long, long periods of time. They usually will become inactivated after a year or two. So rotation can actually be a successful way to reduce the level of primary inoculum in your field. Another way that sometimes sclerotia can be added to the field, though, is if they're present in the seed. So if we're using harvested grain or bin run seed and it has ergot bodies, we can potentially be returning those. Oftentimes cereals are seeded at a depth that the ergot sclerotia, those stalks on the germinating sclerotia aren't long enough to get up out of the ground. So some cases it's not an issue, but it's important consideration. Now I've got tillage here with a question mark behind it. Burying the sclerotia is a viable way to prevent the primary inoculum from being released in your field. But there's lots of reasons other than ergot to make tillage decisions on your farm. So in my opinion, ergot would have to be a really serious problem before you'd look at plowing under or trying to burn residues. These can have an impact on the amount of primary inoculum, but they're probably not going to control the problem or prevent ergot, especially if ergot is developing in grassy headlands or ditches adjacent to your farm and coming in as honeydew. This primary inoculum reduction may not prevent ergot. The final thing I'll point out is that seeding rates that affect the amount of tillering can also play to your advantage. So the ergot spores can only infect flowering cereal. So when the flowers are open and they have access to the flower parts. That's the only time that the ergot, and the fusarium too, that's the only time they can infect the head. So that window of time, the shorter we can make it, the more we can avoid ergot. So increasing seeding rates to avoid late tillers is a way to help manage ergot. So I mentioned flowers opening, and there are a couple of things that can affect the amount of time that flowers are open for self-pollinated crops such as wheat and barley. And those are fertility and herbicide applications. And so there are two micronutrients that have been shown to be important for pollen sterility or pollen viability. And so if soils or plants are low in copper or boron availability, then it reduces the viability of the pollen and they won't and so then they have to stay open longer until they can be crossed with some viable pollen. Now, it's my understanding that we don't have a lot of copper deficient soils in Alberta, so it's important to check your soil with a soil test or evaluate whether or not this is going to be an advantage. Because copper itself isn't going to cure ergot, but it can help avoid pollen sterility and it can help reduce the amount of flowering openness in deficient situations, and similar for boron. And the last is that sometimes late herbicide applications can also reduce the pollen viability. So making sure that your herbicide applications are timely can also help to keep the flowers from being open longer than needed. Another option is to control grassy weeds and volunteer cereals. So any of these alternative hosts that can provide a source of primary infection and inoculum, important to control that. And at some point, hopefully, we'll be able to utilize host resistance. So in addition to herbicide control of grassy weeds and volunteer cereals, if you have a field that has a real ergot problem and it's surrounded by grassy ditches or headlands, it may be of value to consider mowing those before they head so that you don't have a lot of primary inoculum building up around your field that can then move in. And the last section here in management of ergot is if all else fails and you end up with a lot of ergot in your field, there are a few tricks at harvest you can do to help avoid the downgrading issues. The first is that oftentimes, as I mentioned, the disease will start at the headlands or at the perimeter of the field and move in. So the outside few rounds of the field oftentimes have the highest levels of the ergot sclerotia. So you can harvest and bin those separately because they may be, if they're significantly worse, then your whole field or your whole bin isn't contaminated as bad. In addition to that, I mentioned that the ergot sclerotia become very loosely attached, and so they can dislodge and fall off. So if you can delay harvesting or either swathing or combining and let the wind sort of dislodge as many of those as possible, that may help to avoid excessive ergot bodies in your harvested grain. And the final is gravity tables and color sorters can sometimes help with the problem, but you need to weigh the financial benefits of whether or not it's going to be worth the effort to do all that. Anyway, those are some examples of harvest management techniques that can reduce levels of ergot in your harvested grain. So we're now going to switch gears and talk a little bit about Fusarium head blight. And we're going to go through the same sort of outline where we'll talk about the situation, and then we'll talk about how and why Fusarium infects. And we're not going to spend much time on management because we probably won't have time, but I'll point in the direction of some resources. So this is from the Canadian Grain Commission's Harvest Analysis data set. It was published in 2014, and it shows the blue line incidence, or the percent of samples with FDKs, and this is for Alberta. This is Alberta data. And the red line shows the average percent FDKs in the sample. So the blue line is disease incidence and the red line is severity. And so two things we see. The incidence has been increasing over the last 5 years, and the severity has increased a little bit on this graph, but keep in mind that Fusarium tolerances before a number 1 is downgraded are between 0.25% and 1%, and that red line is hovering right around 1%. So that means that the average sample in Alberta would have been downgraded over the last 5 years. So even though that red line isn't very high, it still is significant because it's up above 1%. So the other bit of information we can get from the Canadian Grain Commission's data set is that they record information not just for the province as a whole, but by crop district. And so you can see that there are crop districts 1, 2, and 3 in the south, 4, 5, and 6 in the central/north, and then 7 in the far north. And if we plot the values for crop districts, we get a bit of a messy graph, but again, this is the percent samples that have ergot in them by crop district. And you can see that the red line and the blue line got really high in 2012. That's crop districts 2 and 5. Now, interestingly, crop district 5 isn't in southern Alberta. And so the Canadian Grain Commission's data showed that the levels of, and this is FDKs, Fusarium damaged kernels in harvested grain samples, showed that the level of FDKs was increasing in areas outside of southern Alberta. And that's kind of new. That's not, I mean, the disease has shown up in central and northern Alberta periodically at low levels, but now we're getting evidence from the Canadian Grain Commission that it's increasing. So, as probably many of you are aware, one of the Fusarium species that causes head blight, namely Fusarium graminearum, is a regulated pest in Alberta, and so we're always interested to know what its status is. And over the last few years, we've got most of our information from the seed testing labs, where they've showed us their results anonymously, but to give us an indication. And so here from 2020 Seed Labs, you can see that over the last 5 years, the levels positive for Fusarium graminearum have been increasing. And generally what we find is that there's a pretty good correlation between the Canadian Grain Commission's harvest data and the Fusarium graminearum situation. And the reason for that is that Fusarium graminearum is the most aggressive Fusarium. So if there's a lot of head blight in a field, it's most likely an aggressive species like graminearum. So what else do we know from the seed labs? Well, here it's broken up into different crops, and we can see that durum wheat and other wheats are the most are increasing most significantly, and the other crops, barley, triticale, and oat, not so much. Now I'm going to take you through a series of maps that was produced by Trevor at 2020 Seeds, showing, this is the 2011 map, and the gray areas have no data, the white areas show no graminearum positives, and then a series of pink to dark red show the levels of Fusarium. So if the darker the color, the more Fusarium positives. So this is 2011, and this was common from really the 1990s until 2005, that it wasn't that uncommon to find Fusarium graminearum positives in southern Alberta. In 2012, the situation changed quite significantly, and here we start to see a lot of pinks and reds outside of southern Alberta. This is in 2013. Interesting that, and probably your eye is drawn right away to that great big red spot at the top. I don't know how many samples were received from that area, but obviously there were enough positives that it turned quite red. But again, we see darker colors in the south and pinks and reds occurring in areas where we don't typically find Fusarium graminearum year after year. And finally in 2014, and keep in mind this data set is not complete, they're still collecting samples for 2014, so the complete story is yet to be told, but here's where it stands now. We certainly see that Fusarium graminearum is becoming more commonly occurring in areas outside of southern Alberta. Now, Fusarium graminearum is the kind of organism that, you know, we can't really control where it moves to or becomes established. There are things we can do to prevent it, and there are some best management practices we can do to avoid it. Will Fusarium graminearum become well established throughout the province? Maybe. Again, the story is yet to be told. We've definitely had 3 or 4 years in a row where the conditions are very conducive to disease, and so it could be that the weather has driven this situation, and it could back off if we get some warm summers. But we certainly see that it's capable of being a problem in areas outside of southern Alberta. So here's how and why does Fusarium get started? Well, we didn't see this on the ergot life cycle. This is stubble. So Fusarium is a stubble-borne disease. It doesn't form any long-lived resting spores. It lives in the stubble, and it produces two types of spores, like the ergot fungus, a sexual ascospore and an asexual conidia. And when these get up onto the head during that flowering period, they'll cause head blight. If the harvested grain is used for seed, it can also cause a seedling blight. Here's an example of some symptoms. You can see that salmony pink color just under the glooms on the head on the left. And then you can see some shrunken, chalky colored kernels of wheat and barley on the right. So similar to ergot, when we talk about managing Fusarium, there's not one thing that's going to prevent Fusarium on your farm. There are a number of things that will need to be integrated to be successful. And one of the things I wanted to point out today is variety selection. So the varieties that we have for management of Fusarium have improved dramatically over the last 5 years. And I have this sheet here. This is a color-coded variety select. I know you can't see the slide, but I've got handouts here for anybody that's interested. I'll just leave them at the front. It's a color-coded chart produced by Kelly Turkington and Kei Kwan Shi, indicating what varieties have good, very good, or poor resistance to Fusarium head blight. And then I've listed a number of other things you're probably familiar with. Fungicides can be applied that will suppress but not control Fusarium. Seed health is important, and cultural practices. Because the disease is residue-borne, the amount of residue remaining that's contaminated will have an effect on how much disease will be present the subsequent time a susceptible crop is in that field. The last thing I want to point out is that the Alberta Fusarium Graminearum Management Plan has loads of best management practices for Fusarium, and if you want more information from that, feel free to contact me. There's my information. And with that, I'll conclude. And if there's time, I'll try to address any questions.
Thank you, Dr. Harding. We have a question. Ken?
How well do seed treatments control the graminearum on seed at planting?
So the question is, how well do seed treatments control Fusarium graminearum on seed? The answer is that seed treatments are considered a best management practice. Technically, seed that has Fusarium graminearum isn't supposed to be planted in Alberta because it's a regulated pest. But other Fusarium species that also cause seed decay, seedling blight, and root rots can be managed to a certain level with seed treatments. Now, if you're talking about 5 to 10% of the seed contaminated with Fusarium, the seed treatments can make a significant difference. And we're talking about rescuing stand, so preventing loss of stand establishment due to Fusarium causing seed decay or seedling blight. So they can have a significant impact. If we're dealing with 20 to 30% Fusarium on seed, then it kind of overwhelms the seed treatment's ability to really do much. So it depends on the disease pressure and the situation. But yes, seed treatments are an important part of managing Fusarium diseases because they will cause seed decay and seedling blight and root rot. Yeah, that's a great question. Ergot and irrigation management and ergot. So because those two diseases both attack the open flower during that discrete window of the crop stage, anything you can do to adjust the environment in your favor rather than the pathogen's favor will help. So yeah, managing ergot through irrigation management, that stands to reason. I don't have any data showing the level of impact that you'd get. But yeah, anytime you can turn the disease triangle side of the environment to your favor, and in this case, reducing the amount of humidity at flowering, that should play to your advantage with ergot management. Yeah, good question.